Okay, so we find the mass. And what's mass?
Density divided by volume?
We're not using volume here.
Or whatever your unit is.
It's density times length. And if it was volume, it would be density times volume, not density divided by volume. That's a good thing, because you don't want to be dividing by like r d theta d phi, or rho sine phi, d theta d phi. But anyhow, you got this, right? I mean, this is density per unit length. How do you get mass? You multiply it by density per unit length times length. Okay? So let's just for mass. Okay, I said this is density, and the density is mass per unit length, subitem. Okay? So this is mass per length times length, or mass per length times length, right? This is how we think of it. This is why we multiply density by length. Now, I didn't write down the right words here, so that could have misled you a little bit. Still, there's no excuse. Okay, come on. Now, okay, so we're going to say, okay, delta M sub I, because we're going to use the mass contribution from the ith interval, is density, and it's lambda, not rho, times length, and length is just your delta. Well, what is it? It's your delta S, right? Okay? And lambda is evaluated at what point?
Ti star.
Okay, lambda Ti star. Okay? But density is defined in terms of x and y, right? Okay? So, first of all, Ti star, okay, lambda of Ti star is lambda of x of Ti star, y of Ti star, right? Because lambda is defined in terms of x and y, not t. So, in general, your parameter is used to define your coordinates, which are then used to calculate whatever it is you're calculating on the interval. Okay? And then what's your delta S sub I?
Ti minus 1.
No, it isn't. Delta t is not the length of this increment. I mean, yeah, delta t is the length of the increment. Okay?
Then you say delta S.
But how far do you move on that increment? It's how far, it depends on how much x and y change. Okay? So it's a little more complicated. Now the integral is going to end up being actually fairly simple. You got to see how that works. So let's think about what this delta S sub I is. Okay? If t changes from Ti minus 1 to Ti, by how much, well, how far do you move? Okay? You move along this arc. This is not an arc in T. Okay? Now there's actually a shortcut way you can figure out how far you move along the arc. Okay? But we're not going to shortcut it. We know things about the circle. We could actually use the definition of a radian to figure this out. But in general, you can't do that. Okay? So we want to do something that'll work generally. So in general, how are we going to figure out how far we move? So the point is, okay, it's this times delta Si What is delta SI? It's the distance along the curve from ti minus 1 to ti, but how are we going to get a handle on that?